And I'm live. That is cool. Today is 22nd of August 2025, Friday. And before anything, yesterday was a contest and I was terrible at it. I only solved one question and I was only able to solve one question. And the contest was Division 3. And still, I could only solve one question. That was very bad, not just like bad as in a fact, but the emotions, right? So since then, I have been thinking about two people, two which represent two different concepts. One is David Goggins, and the other is Monkey D. Luffy. And the fact that Monkey D. Luffy is a fictional character has nothing to do with the concept that he represents. And about David Goggins, when he first tried to break the world record of most pull-ups in 24 hours, he failed miserably. He said it himself. And the second time also he failed, but the third time he was able to do it. And he said that he just didn't stop, and this is something that he wanted to do, and he did it. And whenever I used to think about these things, that whenever there is a setback, you should just keep moving forward and not stop. I thought, of course, that is the obvious response. Like, that is the response you would do because there is something that you are trying to achieve, but you fail does not mean that you should stop, right? But no, now that I am actually trying to achieve something, which is tough, a rating of 2000, and I see this, a setback, it is hard to keep moving forward. And I think this is one of the things, or the thing that stops people from achieving very good things. And I have decided I will not let this stop me, and I will continue no matter how many setbacks I see. I will continue. Yesterday's defeat was terrible. It felt terrible. It literally felt very bad, very, very bad. And I wanted to stop doing all of this. Like, what is the point of streaming, right? I cannot even solve two questions in in Division 3 contest. What is the point? But that is the thing that stops people. And it is not going to stop me. This is not just about competitive programming now. This is more about me as a person. I decided this one goal that I'm going to achieve, and now I am going to achieve it. And nothing can stop me. At least I will show up every day. At least I will not stop. I'm just going back to all the things that David Goggins said. I will not stop. That is the first thing, David Goggins. And now Monkey D. Luffy. He says that he will become the king of the pirates. But while he is on that journey to becoming the king of the pirates, he is not enacting as if he is the king of the pirates. That is, being the king of the pirates is not the main thing in his mind while he is on this journey, which he is currently right now. The fact that he wants to become the king of the pirate is pushing him forward. It is giving him motivation in some sense, but he is not living it. He is right now in the present moment. That is where he is. No man, his goal is ahead in the future, but right now he is here in the present. And being in the present is the main thing, right? Because I cannot be back in the past. I cannot be in the future. Present is the only thing that I'm at. And yeah, that was one of the things that I messed up yesterday. And to be honest, I started to gain a few more subscribers than I expected. And that, I guess that made me too happy than I should have been. And I didn't I stopped focusing more on competitive programming, and that was terrible. I started to live in the future, and that is bad. So now the thing is to just keep moving forward no matter how many setbacks we see, and also be in the present no matter how much thing I could achieve. The potential does not matter if I'm not exercising that potential in the present. That is the thing. And now the stream's title: Retreat, Regroup, and Restrategize. I have retreated. I have taken a step back. Regroup. And by regroup, I would suppose it means to look around, see the things that really are, and cut out the parts which are just a figment of my imagination, and then re-strategize. And the strategy is I need to study. I simply need to study a lot. And whenever I'm solving a question, I have to be completely solving that question. That is the only thing that matters in that moment. All of my senses have to be on that one specific question that I'm trying to solve. So that is the strategy, not the strategy. That is a way to solve a question. The strategy is to read and learn and understand things. And one mistake that I have realized I have been making is whenever I see a question and I cannot solve it, I give it more than an hour. And I should not do that because I'm not trying to invent new things here. My goal is to learn, and I can stand on the shoulders of the giants, and I can, instead of trying to not derive, but instead of trying to invent these cross algorithm, I can just read about it and see how it works. So from now on, that is, these are the few points. No matter what, just continue moving forward. Second, living in the present. And third, do not derive things when I can stand on the shoulders of the giants. And I will do my best to remember these 3 points because my memory is very terrible. And here we are. And for today, yes, first I would like to see if my rating has, of course, my rating has gone down, which it hasn't gone down yet, but it will go down. It will go down. And thing is not, right now the thing is not to boost my rating, but to learn as many things as I can. System testing is going on right now, and yesterday I was only able to do this one question. Yeah, just one question. Even though these questions were not that hard, I would have been able to do them if I was in the correct mind space, but I just couldn't do them. So that is terrible. And now we are going to continue with CP31. Like there is this question. I will go through the question and I will not start the stopwatch because this question is challenging, and the fact being that it is in 1400. So my goal with these things right now has to be with learning as much as I can, right? Learning as much as I can after solving a question. Just play with the concepts which were presented in the question and see the tags. And if there is something new, then I should read about those new things. And here we go. But before that, I will reset my tmux. Lera. Tmux attach and 1400. Yep. Start new web. And yep. He gave Eva and Pav are a famous Serbian competitive programming couple in Serbia. They call Pav Papa. That does not matter. Eva gave Pav an array A of n numbers. Let's define F, L, R, and of all the numbers from L to R, L and R included. Here this denotes N. Note that FLR is not defined when L is greater than R. Okay, if L and R are equal, then we would just have one number. But if L is greater than R, then it is not defined. Okay, and I guess we can output minus one, or okay. Eva also gave Pav Q queries. Each query consists of two numbers K and L, and she wants Pav to find the largest index R less than R, which is greater than equal to L and less than equal to N, that is in the range, such that function, the value of that function is greater than or equal to K. Pav wants to solve this problem fast because he needs your help. Okay. And when we take and, the number becomes smaller. And if we try to represent K as binary, if we try to represent K as binary pattern of zeros and ones, let's say K is some number. The thing is, does the highest bit, the MSB, does it matter? The highest bit, that is 1 in K, does it matter? For any number, it would matter. It would matter. It would, shit, okay. For any number, if I want some other number to be greater than K, what I would like is any one of the bits to the left of this one bit. If that is 0, then this new number is greater than K. But if all of them are, if that is 1, then this number, new number, is greater than K. But if they are 0 and this one is 1, then this number would only be greater than K if greater than or equal to K if at least one of these, if all of them are 1 or at least one greater than that is 1. And queries. My screen is visible, I guess. Yep, screen is visible. Hello. Yo, bro, what's your did in the contest? I did terrible. I did terrible yesterday in the contest, and moderator is telling me to stay hard, soldier. Yes, I will. Yesterday's contest was terrible. I only solved one question. Okay, so I want and of a few numbers to be greater than L, and N, the number of numbers in the array, is 10 power 5, and the value of individual numbers is at max 10 power 9, and queries is 10 power 5. 10 power 5. So when I take this data, the maximum time I could take is and log n to arrange these elements in some way so that I can instantly answer this query. Okay, so I need to do some pre-calculation, and this reminds me that there is a section in this book about queries. It was above, I guess. Yep, range queries, something like this. So which means I will have to read this thing after I try to solve this, or it takes me like I could not if I cannot solve this in some time, then yeah, we will have to look at the solution for this. And since our main goal is to study, we will study this thing. Eva also gave Pav Q queries and two numbers. Okay. First I have n, then on the next line I have all the elements in my array, then I have the number of queries, and then the queries themselves. Makes sense. This is guaranteed to answer. and for each query output max, right? And if r does not exist, then -1. And r would not exist if L is smaller than k. If the value at L is smaller than k, then r would not exist, right? Because if it is greater, then you can always output r equal to L. Three, you have three queries, and right, you start with one, index one, which is this number, and you want it to be greater than 7. Okay, if you take and of 15 and 14, I believe I can copy this whole thing. I just stopped building intuitive understanding of things, like comprehensive understanding of what is being asked. That is a terrible mistake. Now 15 and 14, we can represent them using 4 bits. 15, 1 and 8. 8 plus 7, 7 is 1 1 1 1 1 7. Shit, yes, of course it is whole 4 1 because then we have 16. So this is it, and 14 would be represented like this. If we take and, we get 1 1 1 0, and then we have 17. 17 would be 16 plus 1, this thing, and the end of this thing is 0, like absolute 0. So we cannot go to 17, we could only go till here. So the answer would be 2 for this thing. For the first query answer, it is 2. Okay, but while we are finding the answer, we cannot just iterate, because each query, because there are 10 to the power 5 queries, that is a lot of queries. 5 seconds, okay. Shit, 5 seconds is a lot of time, but we have 10 to the power 5 queries, and at best, at let's say in worst case, I would have to go through the whole array, which is bad, right? We do not want to go through the whole array, which is n. So the time complexity would be qn, 10 power 10, and with 5 seconds, is it doable? 10 power 10. Because if I do not do it brute force, is there some information that I could have known beforehand, so that I could have answered this thing just while looking at 1 and 7? Let's say something similar to accumulative sum, prefix sum, but that would not help, because at the end, like, and does not have memory, right? If I have a very big number, a very big number, like a number which has a lot of ones, and then I have 0, then everything becomes 0. So something like accumulative sum would not help. Maybe a matrix representation of this whole thing. Okay, matrix representation. If I do take a matrix, but what would I even represent? Right? Yep. Let's try to do this brute force first, so that I would begin from this index and I will go as far as I can while this thing does not exceed, and then I would return. Yep, makes sense, I guess. Yep. Boilerplate, make the size a little bit bigger, and n, c in n, and vector of integers, size n for auto x, a, c in x, and q, and q, c in q, and for int I equals q equals 0, I less than q, I plus plus, inside int l, comma k, l, k, taken l and k, and now I have to start iterating from l and till k, until I find a number that is smaller than k, that makes this and smaller than k. Now for into j equals L minus 1, because L is 0 indexed, L minus 1 till I till L lower than N, I do not go out of range. And okay, what is going to be the and C and P equals 1, right? And count equals 1, and equals AI AL minus 1. This and is low and is greater than or equal to k. I will do j plus plus. And inside, or I can make this 0 and make this in max, so that most of the bits are 1 except the first bit, which represents negative numbers. Everything is 1, right? This is certainly greater than equal to k. And then I would do and take its and with the current number, which is a j, which is aj. Take its and with the current number, right? And I don't need this count. Take its and with the current number, and j would be incremented. And when I'm out of this thing, either I reached the end or whatever the case, j points to a number that makes the and greater than k. Now, so the answer would for this query would be j minus L range. I need to return R, so j minus L would, or simply j. Yep, j would be nice. J would be nice. See out j. Okay, I can declare j here. Declare j here, and right. But if j equals okay, and before this, if I can do L minus minus, if a L lower than k already, then see out minus 1 with a new line. And that should be cool. Let's see if that is cool. Okay, I was not expecting that. Okay, I messed up a little bit because of this. That makes sense. Little mistakes. Okay, and now, yep, makes sense after every query. Here comes a new line. After every test case. Okay, I am outputting 1, but this should have worked because R is 1 indexed. R is 1 indexed, and my j points to something greater than R. Well, let's go for this first case. Here L was equal to 0, so j started at 0, and it saw that this thing is greater than 7, so that is cool. Then G went on to this thing, which is 2, which is J equals 1, index 1, and of these two things is greater than 1, is greater than 7, so that is cool. Then we went on to this where J was equal to 2, and 2 is the answer, and we should have makes sense, because after taking this, J was also incremented here. J was also incremented here. Uh, Here makes sense, makes so much sense. So I can and pnt equals 0 and count plus plus and l plus pnt. How much further I went? That would be wrong. 0 plus 1, 2. Let's see. And also about the end, 3, 2. Yeah. L would be 0 and I went there. It became 1, 2, and 3. So answer that I outputted became 3, which is wrong. I literally do not believe that I will be able to reach 2000, but I will continue. This thing is wrong and this thing is wrong because I reached the end. If I ever reach the end, then I index the maximum. If I ever reach the end, at end, if I started here, 5, 1, 2, 3, 4. For this thing, 4 and 5, I begin from this index and taking add of this and this seems to be, it would be greater than 5. And then I do not go in, right? So I can test it with my J. Here, if J greater than N, question mark, then N, else, if, and that should have been fine. That should have been fine. That should have been fine. 5, why do I say bad things? Okay, 4 and 5. If J greater than N, J plus plus and greater than equal to K, if J is greater than N, I went out the other side. So output N, otherwise output how much I went further. So somehow this thing is wrong. So that thing is wrong. Yep. When I'm going out the side, it should have worked. 4, and I'm looking for if it is greater than 5. You will see. New, yep, it is C++. Yes, bro, any tip for recursion dynamic programming? Yes, you can read CLRS. CLRS has a very nice bit about recursion. Uh, there's a whole chapter on dynamic programming, and it starts with a simple rod cutting example, dynamic programming. And this is thick, like this is research level algorithms. This is research level algorithms, but this book, I have not read the whole thing. I have only read a little bit of this part of this chapter about rod cutting, but the way that they represent the problem and then the solution is very elegant. It is very comprehensive. And this is very cool. You can read this dynamic programming part in this Introduction to Algorithms book. And from this, I read about, well, very long ago, I read about heap sort and quick sort for my college at some point, right, in the last semester. And I read this part and it was amazing. It was amazing. They talked about recursion tree model for solving recurrences. And in this whole thing, the only thing that I was able to get was that there are things called invariances which stay even when you execute the loop, and when you terminate a loop, those invariances stay, and that can help you make an algorithm, that can help you to decide what variables to begin with, what changes to make throughout your loop, and what things to expect when your loop exits. So that is cool. But shit, what is the invariance here? What is the invariance? Okay, I'll and K. This seems unnecessarily harder than it is supposed to be. L minus minus, so to make L zero indexed, and then I see immediately if the thing at L, if it is lower than K. If it is, then output -1. Else, if it is not, then I will start taking AND of every number starting from the current L I am at, and I will keep moving forward. Okay, and this is the loop. So invariance, there has to be invariance. Okay, right, shit. If I think in terms of invariance, which I should, which I should, 0. C and T represents how many steps I have taken from initially from L. That makes sense. And I will only do this and if and with the current number. If it is greater than or equal to K, I will only take the and in that case. Okay. Otherwise, break. I don't even need all of this now. And I can just do L plus CNT. But CNT represents how many steps we moved. And yes, since L is zero indexed, L is zero indexed. So if we start with 0 and we took one step, it would be L plus 1, 0 plus 1, it would be 1. So 1 would be the answer. So that is cool. That is cool. We can do this. Let's see, answer is correct. Shit, just use invariance. Okay. But the error here is most certainly going to be in this time limit exceeded error, because this is very, wait, what? Shit, is this because of system testing? Okay, okay, it is running and time limit exceeded error. I suppose I would see. Okay, on 8. I think time limit exceeded. Okay, it is still running. Okay, we can, I guess, in some way reason through this thing. Time limit is 5 seconds, and 1 second is I think it is equivalent to 10 power 8 loop. What is equivalent to 1 second of compute time in terms of length of a loop code. Shit, this was in CP. Yeah, this was in this book at the very start. Shit. Something right here. And how is the thing going? Yeah, time limit exceeded. Makes sense. Introduction and programming languages, input and output, working with numbers, modular arithmetic, floating point, shortening code, macros, mathematics, set theory, logic, functions, logarithms, contexts and resources, time complexity. Yes, time complexity. I'm just looking for how long a loop normally we can take with our given time limit. Recursion takes a lot of time. Time classes, effective efficiency, input size. Okay, R10 is about this. So what we need is O of 1, O of n or log n, but we do not have that. We are having n square, so that is bad. And since we do not have to invent everything that we are seeing, I think this was a ego thing that I didn't wanted to look at the solution. Yeah, most likely it was a ego thing that I didn't want to look at the solution. But I need to grow, right? We need to become stronger. And my AC is off. I need to turn off the fan. Wait a minute. Yep. And now, so we can look at the solution in a bit. But before that, we can ponder about this question. What we have is an array of numbers. What we have is an array which has a lot of numbers, and we should try to represent them in binary. And what I want, like this thing, I have an array of numbers. Let's take any example from this, like this thing. And if I were to represent these numbers in binary, 15 would be 1, 1, 1, 1. 14 would be 1, 1, 1, 0. 17 would be 16 plus 1, so 1, 0, 0, 0, 1. And 42, what would be 42? 42, 30, 32, 32 plus 10, which is 8 plus 2. So 0, 1, 1, 0, I think. This should be, this is 2, this is 8, this is 16, this is 32. Wait, I messed up. 1, 2, 4, ah, 0, this is 0. 1, 2, 4, and this is 0. Right. This is 8. Right. This is 42. Then 34. 34 is 32 plus 2. 1, 0. 0, 0, 1, 0. And what can I do? If I take AND of every single pair, take AND of these two, I will get 1, 1, 1, 0. Take AND of 15 and 17, I will get, I can write this in a table. That would be much better. 15, 14, 17, 42, 15, 14, 17, 42, and 34, 34, 34, and this does not matter. But here we have the AND equal to 1, 1, 1, 0. Then with 17, shit, everything is 0 except the last bit. So simple 1. And with 42, this is 0. This is 1. Okay, we have 2, 0, 1. We have 8. So 10, 10. And in binary, 10 would be 1, 0, 1, 0. That is 10. Now with 34, only this bit is 1. So 1, 0, which is 10, which is 2. And then, yeah, everything here is done. Here, no need. And then 14 and 17. What am I even trying to do here? 14 and 17. Okay, so what even is the goal with this? I just need to find one number, the furthest I can go. Wait, is it like knapsack? I haven't read about knapsack. Like, I know that in knapsack we have some kind of table like this, but is this like dynamic programming? If I shrink my range, I don't think so. Yep. Okay, we can look at the solution now, which is not bad, because we are learning. This feels very bad to look at the solution. Okay, this one problem was authored and presented by these guys, which is cool. Hence, try calculating this bit by bit. Bit by bit. Bit by bit. Bit by bit. If bit by bit from the MSB, if they are common, then cool. I do not need to know anything beyond that. But if they are, here we have 0 for something like 15 and 17. 0, 1, 1, 1, 1. Yep, 2, 4, 8. Yes, that is 15. And for 17, we have 1, 0, 0, 0, 1. And bit by bit, if I begin with this bit and this bit, it is 0. It is 0. Okay. And my target is 15, which is this bit, and this would still be greater than or equal to 15. if this bit meets, so I move on to this bit and I see that it is also a 0, so that is bad. And so yeah, I do not have to look at these bits, but that does that help? Because I could simply take AND of these two numbers and compare it with 15. So what is the point? Which condition has to hold true for all the elements on subsequence disk for a certain bit, for that bit to be present in this. Yeah, if what condition has to hold true for all elements on this and for a certain bit for that to be present in this, for a certain bit for to be present in this. Okay, okay, shit, okay, okay. So if I have a number like this 15, then it is represented like this 1 1 1 1. And if I am looking for a bit, like let's say here, then if that bit is present, then that bit has to be 1 in all of the numbers in that range. And if it is 0, if the target bit is 0, then even if it is 0 in just one number, I will get a 0 here. So if I have 15, I want the answer to be greater than or equal to 15. 15 is this many bits. 1 1 1. So either I want one of these bits, I want all of the bits in this range to be 1 for this. I will check them for this, then I will check them for this, and if it is wrong, then we messed up and we can start moving from left to right for all of the bits and keep shrinking the range. So what I need is some way so that our pattern was 15, 14, 17, 42, and 34. This was our input number. So is there a way which I can use to see for a certain bit till which number it is 1? Starting from this range, right? Yeah. Since these are, what is the maximum range of the numbers? 10 power 9, 10 power 9, 10 power 9. How many bits is that going to take to represent 10 power 9? Okay, yeah, let's represent these numbers again as binaries. 0 0 1 1 1 1, that is 15, and 0 0 1 1 1 0 14, then 17 0 1 0 0 0 1, that is 17, and 42 is 32 plus 8, this is 16, this is 8, 0, this is 2, and then 0 for 1. And for 34, we have 32 plus 2, and everything else is 0. Okay, if I can, while I'm taking the input, I can see for all of the numbers which have this bit equal to 1, these are the numbers. Okay, if I do index them with 0 1 2 3 4, can I do this? Uh, let's say here I am using 6 bits to represent these numbers. So I can do this 3, 4, 5, and 6. 1 bit the numbers which have their one bit equal to 1, uh, which have their one bit true. While I'm taking the numbers, I can do this. Take a range and store it as a pair. Okay, when I see this number, I will see all of the bits. I cannot start a counter. Okay, I need to store this information in some useful way. So that when I query for a given certain bit, I would know the range in which that bit is 0. And if my L falls under that range, then it is good, and I would see how far to the right I can go with this bit. But how do I store that information? If we do this for just one bit, let's say for this 0th bit only, and then we would have something like this 0 1 1 0 0, and initially our counter would I the iterator would go from 1 to 4, from 1 till 4, and we could, okay, when this bit does become equal to 0, we can know I. Can we use I to know if the last bit was 0? Yes. So I would either encounter a 1 or a 0. Whenever I encounter a 1, I would see, was there a 1 before this? If that is, if there was, then cool. If there wasn't, then I will have to do some things. If there wasn't, then also fine. Then also fine. But whenever I see a 0 and I see that the last one was 1, then I would need an index for the last one that I saw. Okay, so whenever I see a 1 for the first time, that is before that either there was nothing or there was 0, then I will add a pair. I can add a pair in which the first number would store the index of this one, right? And whenever I see a 0 where the last bit was a 1, I would access that pair, and in the second part of that pair, I can add this number. So that at the end, I would have everything. I would have these pairs which represent ranges in which this bit is high. That is cool. That is that is cool. That is cool. That is cool. And when I'm trying to represent 10 power 9, how many bits does that take? Can an integer represent 10 power 5, 10 power 9? Yes, yes, it can. 10 power 9 is 1 billion. Yes, integer can. So 32 bits would be the way to go. And I will do this while I am taking the input. So I would have to create a vector of size 32 of vectors which has pairs. Shit, that is crazy. Instead, I will use a vector, not anything else, not like a static array. Let's call this prefix and vector. How many elements? 32, and vector of pairs. And how many elements does it have? Nothing. It is empty. So that is cool. And whenever I take in a number, I cannot run my loop like this. Int I less than n, I plus plus, and I can actually turn off my fan because the AC is back on, which is cool. Yo, there is a lot of lag in the stream. I guess it is more than 10 seconds, which is a lot. 10 seconds is a lot to have a conversation with a human being. Like 32. Okay. For every number that I take, C in C, take in C, and now inside with this number, I'll run a loop for int x equals 0 till, and I would be left shifting 1 by x amounts. So 31 is going to be the max, less than 32, I plus plus, x plus plus. Now I am at a particular bit. If, right, if take and with this thing, if C and 1, 1 left shifted by x amounts, if this particular bit is 1 that I'm at, I need to check if the last one was 1 or 0. If it was 1, then nothing, I do not do anything. If it was 0 or it didn't exist. Now, if I equal, if not I, that is, this is the first time that I'm seeing, this is the first number and it's 1 bit is 1, so I need to add it into the data, or the last bit was also 1. If I, if not I, or how do I access the last bit? To access the last bit would be the same bit, a I minus 1, take its and with 1 left shifted by x. If that was 0, if not this, right? If this is the first number and there is a bit there, or if this is a 1 and the last bit was 0, then I need to append this to my pair. Prefix at index x dot push back a pair with current index I and 0, 0 or let's say minus 1. Does not matter, that is cool. Else if this is 0, then if the last one was 0, then does not matter. Now, if, okay, shit, this condition should be inside. No, 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 this is fine, this is fine. I don't need to click else here, else here. Now, if I'm seeing when I need to make an action, if if this is not the first time, and the last bit was 1, and I minus 1, and with 1 left shifted x times, if the last bit was 1, then I need to append this prefix x dot back, get the last thing, dot second equals I. That is, I started from I and I went till this number. This is my range. I think I should append I minus 1 because I want my range to be inclusive. So I minus 1, and let's now test the data. I think I think this is cool. This is cool. I should have everything that I wanted. Prefix. So whenever I see a query, what I need is I will go, whenever I see a k, let's say like in the first case, my k was equal to 1, 1, 1, 1. So what I could have is have a 1 at any of these places. That would be very cool. Or have a 1 at least at these places. But I have a restraining order with the L because of the L that I have. I cannot just choose any arbitrary range. So, so first, do I narrow down my search given these bits or given this L? I won't be able to do it with the L. I won't be able to do it. Okay, so yes, I can start bit by bit. If I start bit by bit, I will see in which range is this bit equal to 1. And if it is inside my L, that is cool. That is cool. Then I would move on to, I will put that to my range, and then I would move on to the last to keep moving on, keep moving on. And if this new number overlaps with the current range, I will extend, I will take the union of the two ranges. That would be cool. But I cannot go left. I can only go right. Yes. So whatever the range is, I can just return the rightmost index from that range. Okay, then keep moving forward, keep moving forward. And I would need this bit to be 1. And if I see that the range in which this bit is 1, so there is this thing where I need all of these to be 1. Not need, it would be nice if I could. Right. I would exit. So yes, when would I exit my loop? I would exit my loop. I would exit my loop the first time that I see that this bit that I need is outside my range, is out that I need. That is a part of k that represents 1 bit in k. If I see that it is outside my range, then I can exit. Right. Okay. I maybe could have chosen a better model to represent the data. Okay, let's go with this. So we have L and K. With this K, with this K, so there are two kinds of loops and two kinds of things. First, all of these bits, which would be nice if they were 1, right? So first I can run two separate loops for these. One loop for checking these bits, these optional bits, and one loop for these essential bits, which I need to be at least 1. Yep. Due to some reason, I feel very slow. Okay. So I want for optional, how do I know? The highest bit in X. Just run a loop 32 times. Right. Int X equals 31 and while 1 left shifted by X taking its and with K is equal to 0. I think there must be a general loop method which I can use to not make this loop two loops, one loop after the other. But this is what we have right now. So we will go with this. Lift shift 1 by X amounts and see if it is not, if it is 0. If it is 0, then keep running our loop, and initially our range is from left till right. Int r would be equal to, I can check one thing beforehand. If, and yes, left and right are 0 index. If AL is already lower than K, then C out -1. C out -1. Right. So now at least I know that my R equals L, which is nice. Now I will look for the ranges. I can go through the ranges, but what if, yes, not just any range. I will go through the range which is closest to this thing, for which I can use upper bound function, but using an upper bound function on a set of pairs. How do I compare the paired shit? This is cool. This is not very practical, but this is cool. Bool operator. This takes in a const reference to a pair of integers called p, and a const integer reference called c, right? And then return. I want the first, this pair, return p dot first lower than c. Right. P dot first lower than c. Now I can call the upper bound function. Upper bound function. Yes. All of this seems very abstract. Call the upper bound function on prefix x dot begin and prefix x dot end with what, with L. Bruh. Okay. Ignoring return type with noise card in IT or auto IT equals system invalid const int and const pair. Okay, I have to change the order, I guess. Wait, upper bound can call them in any order. So I can override the operator. Const pair in p with, but now you would have C here and p dot first. First is the only thing that we get out, and we still have some error here. Constant and invalid operand to binary expression. Operand to binary expression. Custom compare function. I guess a lambda function would be nice. This is the thing that I posted about in one of my posts, passing a custom compare function in the upper bound thing. I guess I'm making this more complicated than it needs to be. Auto iterator upper bound. No, it is already sorted. Right, it is already sorted. That is, I know that. Right, I know that. So I need a L pair that is either equal to or lower than my current L range. And it would be pretty nice if I could just call this function like this, but apparently I cannot. So we are going to do the more complicated thing and do this. Bool compare equals a lambda function which takes in a few things, auto const p and auto const reference c. Huh, yeah, that should have been nice. It is nice. Okay, now compare the types. If dk type, if compare type is there is some function compare less. There is a function for this, for comparing types, function to compare types, uh, or not a function but a a macro types in C++ is same dkt for declare type of p. Is it same with int? Okay, I can remove one of these. Okay, it's same. Yes, is it same with int? Expected find id. Make it a constant expression. Declare type of p, pass it into dk type to remove everything extra like const and a reference and auto and stuff like that. Is it the same with int? That is how you check things, right? Is same char and signed char dot value is same value. Okay, is that what you do? Shit, that is what you do. Okay, if the first one is an integer and is same dk type, declare type of C, declare type of C with, yeah, I messed up a bit. I would like to change this from an integer to a pair of integers. And if that is true, then return p dot first lower than c, else return c dot first lower than p. Now I should not get an error here if I pass in c m p. What is the name? COMP. That is cool. That is very, very cool. A custom compare function to binary search the things. Uh, okay, but this might be very wrong. Let's see. Let's see. I will have an iterator if it isn't equal to prefix, and yes, at this point, it is like less about solving this question and more about seeing stuff, I guess. What even is the syntax? Okay. Dot first pay. Okay, and here space, a little bit of space, and then go to it dot second, so that we at least know that we are getting a find range in this. This is terrible. This is horrible. This is horrible. Let's even make something for this. Okay. And OS stream would be returned operator, this thing which takes a constant OS stream reference called OS, and on the other side takes a constant to a pair, not even integer. We can make this a template of type name t and pair of tt type, a reference to that pair. Let's call it x. Yes. So here you would return OS takes in this bracket and then x dot first, then a comma, then x dot second, then ending, and then a new line. That is somehow wrong. Shit, I've seen this error before. I have seen this error before. Makes sense because it is a constant, right? Call to, okay, will this work now? How do I do this with a vector? I have something to print a vector. Print vector. I take in the OS stream error. That makes more sense. That makes more sense. If I'm it just doesn't have to be a constant. Yep, that makes sense. And when I'm trying to print it, cout prefix x, print it directly, and there should have been no error. Yes, there will be no error. Yeah, cool. This will break, of course. And those minus ones are not very beautiful. Shit, everything is lower than k. Somehow. Of course it is. Because I didn't add anything. AI equals c. Everything is still lower than k. Okay. Take in c, AI equals c, right? Take in n, then take in all the values. AI equals c, and then we are going to q. I am new Python programmer. Any tips? Vladimir Putin. Uh, yep. Make projects, maybe making projects. And in Python, you can do AI things. That is cool. AI things are cool. And you can go. There is CS50 Python, which is an amazing thing. They will tell you about projects that you can make CS50 with Python, and you can do this thing self-paced. And there are difficulty. You can do this course, which is free and online and pretty cool. Pretty cool. It teaches you a lot about Python and stuff, projects that you could make with school. I guess at this point, I should look at the solution because it has been very long. Yeah. How can we check if that condition is true for a certain bit fast? If we have try prefix sums, try binary search. I have kind of prefix. I am using kind of binary search. Let's see in Russian. We can for each bit calculate the prefix sums for array. Okay, shit. That makes a lot more sense, I guess. Shit, that makes a lot more sense. Shit, that certainly makes a lot more sense. Shit, that does make a lot of sense. Instead of all this shit, and n, c and n, and a is going to be a vector of integers a of size n and empty vector for int I equals 0, I less than n, I plus plus, and we take in the new number and c, and let's say const bit equals 32, and here we will go for int, yeah, int x equals 0 till x lower than bits x plus plus, and f, we not call this a, we can call this prefix, and n plus 1. Zeroth one is always 0, so we can begin with this, right? And if 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 one left shifted by x I take its AND with C. If there is a bit at location X, then I would do prefix X, prefix for the ith number, the xth bit plus equals prefix I minus 1 for the same bit plus 1, else 0. Size is going to be 32 and everything is initially 0 for this inner vector, and that should be cool. Then int q, c q, and then for int I equals 0, I less than q, I plus plus, and int l and k, c in l and k. Now I know int c current bits would be equal to prefix I some bit in number x gives me the number of bits that have been till this point except the point before, right? So L minus minus to make it 0 indexed. Yep, L minus minus to make it 0 indexed, and in my prefix sum to know the number of bits at a particular index I plus that index, I would have to do I plus 1. I plus 1 would contain all the bits, included that bit also. And here, if AI, I do not have AI anymore. I only have that bit things. So this representation is cool, prefix. Would I also like to store the numbers? I don't think so. Now I can start iterating from top to bottom. And yep, from top to bottom. If one bit in k, if the current bit in k is 1, and okay, what do I need? I need to see for some particular bit how much does it extend if it is 1 for the current number that I'm at, and how does it grow, how further does it grow. Prefix and binary. I think I'm messing this up a little bit. Yes, I think I'm messing this up a little bit. Shit, I am looking at the tutorial way too much. Okay, prefix I and j, where I is the number and is the number of occurrences of the jth bit in the first I elements of the array. In the first I elements of the array. Jth bit in the first I elements of the array. This can be calculated in n log max a time max a is 10 power 9. We know that if prefix r j minus prefix l minus 1. Okay, this shit. Yeah, I would like to come back to this question later. This is just not clicking to me right now. So yeah, I would like to come back to this question later. Regroup, re-strategize, retreat. Yep, come back to this question later. Yeah. Now, bracket coloring. CSES. Are there questions about prefix? One question. Range queries. I would have to do I would have to do these questions. Range queries. They are cool. Range queries. They will help me. And not just complete them, but actually understand how things happen. Mm. Okay, now with this question, a regular bracket sequence is a bracket sequence that can be transformed into a correct arithmetic expression by inserting characters 1 and plus between the original character and the sequence. For example, the bracket, this is correct, and this are regular. The resulting expressions are this, and and this, right? The bracket sequence, this is wrong, and this are not. The bracket sequence is called beautiful if one of the following conditions is satisfied. It is irregular if one is satisfied. Okay, identifying if it is a regular thing or not is easy. If the order of the characters in this sequence is reversed, it becomes a regular sequence, bracket sequence. If the order of characters in the sequence is reversed, it becomes a regular. For example, the bracket sequence, this is cool. This is also cool. Reverse. Every bracket is reversed. Okay. Okay, if everything is reversed, I guess. The, if the order of characters in this sequence is reversed, it becomes a regular bracket. If the order is reversed, that does not make sense. It would just reverse, flip over, wouldn't make any change. Okay, T, N, okay. Each test consists of two lines. First, N number of characters in S. The second line is this. You are given a bracket sequence as you have to color it in such a way that every bracket is colored in one color. For every color, there is at least one bracket colored in that color. For every color, if you write down the sequence of brackets having that color in order they appear, you will get a beautiful sequence. Color the given bracket sequence S into minimum number of colors according to these constraints, or report if it is impossible. Okay, this is beautiful and this makes sense. For every bracket, color it into one color. For every color, there is at least one bracket colored into that color. For every color, if you write down the sequence of brackets having that color in the order they appear, you will get a beautiful bracket sequence. Okay, color the given bracket sequence S into minimum number of colors according to these constraints, or report if it is impossible. So I can start seeing how far I can go with a bracket sequence that is beautiful. And when I stop, I will start recording, looking for another bracket sequence. It is a regular bracket, that makes sense. But what does this line mean? If the order of characters is reversed, if the string is just reversed like that, it becomes a regular bracket sequence. How does this thing become a regular bracket sequence? If the order is, okay, this one is the last, this becomes the first. This one is second, this becomes second last, I guess. Okay, not mirror image, but order reversed. Okay, like that. Okay, so if it is even, then these go to the left and right. Okay, that makes sense. That makes sense. Time complexity 2. Identifying a regular bracket sequence is fine. But then identifying a reverse one is bad, and one bracket into one color. Okay, for every color there is at least one bracket in that color where each character is this or this. Additional constraints on the input, the sum of n and overall test cases does not exceed 2 power 5. For each test case, print the answer as follows. If it is impossible to color the brackets according to the problem statement, print -1. That is when I do not find any regular sequence of brackets, either regular or reversed regular. Otherwise, print two lines. In the first line, print integer k, the minimum number of colors in the sequence. In the second line, print n integers like this, where ci 1 to k, where ci is the ith bracket. If there are multiple answers, print any of them. But also I can skip brackets, which is cool. Shit. Every bracket is in one color. Okay, this much is one thing, and then this is another thing, right? Okay, minimum number of sequences. Yep. So what I can do is I can start iterating from the start and keep going as further as I can and see whenever there is a zero, right? And if there is a zero, then it is cool. I have seen a regular sequence and all of them would be in a single color. Okay. And when would I return -1? When I never see a zero. Okay, I think we can do this. This would not be too difficult. This should not be too difficult. Boilerplate, then like int n. And now the bracket sequence, string s, c in s, and int a equals 0, and s vector would be very nice. Yeah. Int k equals 1, and a vector of answers would be very nice. Yes, I can only know when I go till the end, right? Yeah. Yep. For int I equals 0, I less than n I plus plus, and int left equals 0, and if si equals left bracket, then left plus plus, and else left minus minus, and if at any time left equals 0, then something I can store the answer in an array vi array of I. But minimum number of colors, minimum number of colors, minimum number of colors, that is what I need, minimum number of colors. Minimum number of colors, I can plot a graph for the value of left as it grows. If it is 0 at the start, and if it goes up up like that, then all of these could be colored in a single color. But if it ever goes down, then this has to be a different color. All right. Yep. Yep. This has to be a different color. So whenever I see a 0, that is fine. That is fine. But after that, if I see a positive, then it is cool. I will keep adding the same color. But if I see that no, the last bit was +1 and now it is this, then it is bad. So I can store the value of left and then go through all of these, but it would be better. It would be, I could do this on the spot while I am traversing through my array. Value of left goes up, 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 and down, down, down. While it is positive. Okay, while L is not equal to negative, and it can go to negative and positive. Whenever its sign changes from positive to negative, and 0 is both positive and negative. Okay, I can keep a thing int a size n. What does that mean? Int sign equal or bool sign equals true. What is true? No, initially it is 0, so int sign equals 0. Now if at sign, right, sign, if if sign is either, if sign was 0 and 1, it would not matter. But if 0, 0 would matter. 0 would matter. If the last sign was 0, then I need to do something. If the last sign was, I don't know, I can make sign equal to, depending on the first bracket, S0 equals opening. If it is opening, then 1, else -1. Now I have to check the sign of left and sign, right? If it is positive or what. If, but to change sign, it will have to go through a 0. If sign, that is true. Sign, if sign, then change its value depending on left. Sign, yes, if sign, then sign equals, if left is greater than 0, it could have three possible values, 1, 2, and 3. No, -1, 0, and 3. If not left, if it is 0, then sign equals 0. Else sign equals left greater than 0. If left greater than 0, then +1, then then 1, else -1, else -1. If sign was not there, if sign was 0 and now I have some value, then also it does not help me. It does not help me because I need to know what the last bracket was. Now, if left greater than 1, then something else if left now is less than that. And this would all depend on whatever. Wait, I don't even need this. I could just check if at any point left is +1 or -1. That would indicate it was 0 just before this, right? I don't need the sign thing. So if left equals -1 or left equals 1, right? Then the last one was 0. And I need to know what the thing was, the third last thing. If I greater than 1, that is I equal to 2 or greater than that, then I can go 1 before that. I can go 1 before that, but how would I know the sign of that? Then if Si minus 2 minus 1 was 0, -1. -1. If this thing equals closing bracket, then I must have done a negative left -1 operation. And if I did that and that made my answer equal to 0, if I did that and that made my answer equal to 0, that means left was positive, and now also it is positive, right? Now it is one of these, right? Okay. If left equals negative, right now I just went below, but if it was positive before that, I greater than 1. If I greater than 1, I can go back. If I if I if I and the last one was a closing bracket, that is I reduced n, then a plus plus. I have to start a new color. Else if left equals +1, and inside I have to see if left is now +1, then I would like it to be -1 before that. If then I would like it to be -1 before that. If I and Si minus 1 equals closing bracket, opening bracket makes L plus 1, then A plus plus. And whatever the case is, AI equals K. Now for int I equals 0, I less than n, I plus plus, C out, AI space new line, I equals n minus 1. This is correct. Okay, I need to output the number of colors. Okay. C out, A, and a new line. and also if it is doable or not. But I could also come to L plus 1 and minus 1 from 2 and minus 2. That could also be the case, right? And if that is the case, if L is right now minus 1 and the last bracket was opening, was closing bracket, the last bracket was closing bracket does minus 1. So the only way I could have gotten here if I crossed the line. Yep, it was 0 and I came from the other side. That is cool. That is that is cool. Yep, that is cool. That is cool. Because from minus 2 to get to minus 1, I would have to see a opening bracket, but that is not what I'm checking for. I'm checking for a closing bracket. And the same argument could be applied here. Here I am looking for a opening bracket which increases left by 1. And now what if there is no answer? If there is no answer, then I need to know if at least it was, then this thing at the end, left has to be equal to 0, right? Left, if left, then C out minus 1. Okay, that is cool. That is completely cool. Two colors. I could have done this in one color. Here also two colors. Okay, I could have done this in one color. Colors is bad. I could have done this in one color. Here we have this. Here. Okay, this and this. Okay, shit. Right. Two colors does not make sense. Why do I increase left? Okay, what is left at the end of this? CD 1400 and clang plus plus. What is the thing? It is called B bracket dot slash out. Run it and we would go for that thing. One test case which has 4 stuff. Let's go. And L was equal to 1. Then it became 2. Then it became 1. And then it became 0. Right. So it was always on one side. 1, 4. And we have closing, closing, opening, opening. Then it then also it was -1, -2, -1, 0. So when I see this one, I'm treating this as an increment of k, which is bad. I shouldn't do that. Why am I incrementing k? If left equals -1 at this point, when I'm here, then I see this thing. If that is a closing bracket, and it is a shit. And it is a closing bracket. But when I see a closing bracket, I'm doing minus minus. last equals 0. And if at any point, if left into last, if it is negative, less than 0, then k plus plus. And last equals left. How about this? Yeah, this is wrong. Everything here is correct. But this is wrong. And I'm being very terrible here right now. Okay, last is very bad. Last is bad. Shit, shit, shit. I need to check the sign of the last one. Shit, 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 shit. Okay, what is wrong in this? I'm going to the last one, and last one, I see if it is closing. Closing reduces, closing does -1. If I had 2 and I saw this, I would do 2 minus and so on. Okay, is it because I'm doing this before? Okay, I did some choice. I made my operation right now for this current letter, and my left is either -1 or +1. And if it is -1, after making this current move, like at this point it is -1, and here also at this point it is -1, I need to look at the current bracket. I need to see if the last one was 0. The last one would be 0. Opposite, it came to 0. No, it didn't come to 0. Point it is +1 or -1. Here it is -1, and here it was -2 because of this. And what if it were 0? For it to be 0 here, for this thing to be 0 here, what would I need? And 0 coming from +1. I think I do not need to know everything before this. I only need to be concentrated on, no, I need to know that thing. I need to know this thing. If it was 0 and here it wasn't 0. I know if this is a closing bracket, then the last operation that I did on that would have been -1, and that is also true. Okay, if it was minus was the last operation, and right now I did a plus operation. That makes sense. If the last one was a minus operation and SI is a plus operation, which is represented by opening bracket. That makes sense. That makes a lot of sense. And here, if the last one was a plus operation, then I need this one to be a plus operation as well. Why would I need this? Yeah, I need both to be the same, right? If they are same, then shit, this should have been very obvious. Shit. If L equals this, either -1 or left equals +1, and if I and SI equals SI -1, then K plus plus. Okay, again, I can stop, not do this thing, and I have a recorder on. Okay, 3 is bad. 3 is bad. 3 is very, very bad. 3 is increment. Okay, 3 is bad. 4, 1, 2, 3, 4. Ah. So here it would have been 3 plus 3 -2 -1. And okay, shit, that is very bad. That is bad. Shit. And the last value was 0. Last value was 0. Okay. Last value was 0. Last equals these things, and not last. Last was 0, or last equals left. Okay, this is correct. This is correct if the last one was 0, and I have been making the same move, and I am at either this or that, or I must have crossed the line. At that point, I will do this. Makes sense. But is my last changing correctly whenever I move on to the next one? I put my last equal to the current one, and I find the next one. So that is cool. That is cool. That should work. You'll see. Hello, Captain. How are you? You are in your 4th year and you are not 45 years old. That is cool. Bracket. Yes. Let's see if that works. If this works, I would be happy a bit because is it taking tool? Answer is kind of wrong. Actually. Shit. Okay, it is fine. It is fine. Stream is fine. That is fine. Answer wrong. Okay, I do not want to look at the test case. Okay, I take in N and I take in S and I initialize K equal to 1. But if I do see left, yeah, I would output -1 if left is not equal to 0. Then left equals 0, I initialize left to be equal to 0, and vi, the vector that will have the answers, right? And last equals 0, right? Last equals 0. I would not check it if I is not there. not last equals to 0, right? Now, depending on the current bracket, if current bracket is opening, make it opening left plus plus, otherwise left minus minus. Then if left minus 1 or left plus 1 and last was 0, and last was 0, and there is a I and I have made the same move, then I must have crossed a boundary. Yes, shit. I can take all of the positive ones in one color and all of the negative ones in one color. That makes a lot of sense. That makes a lot of sense. Okay, let's say k equals 1 is going to be for positive. K equals 1 is going to be for positive. Okay. If current is negative, if current is negative, okay, I can group all of the positive. But can I also group? Wait, would I ever need more than two colors? Would I ever need more than two colors? If I have this thing and I have two of this, let's say I have this twice, let's say right here, then I then I could choose these as one thing and these as another, and it would work. It would work, let's say. And here I have opening, closing, something like this. Shit, then all of these, could they be in one group? But the order would depend. Order would depend. It would I can most certainly take all of these which are already regular in one group. But the question is, can I take all of these which are out of order in one group? And I think I can if there are if I have okay, I'm guaranteed to have a equal number of brackets in that range. Shit, I just feel like I could just give up and don't do any of and not do any of this. I can certainly add all of the regular ones in one group, but the question is, can I add all of the other ones in one group also? Like this one and this one, anyone? I think I can. I think I can. If I have a sequence like this, if I have a sequence like this, I put it here and another sequence right here. If I reverse this whole thing, put all of these onto the right, all of these, Okay, if it is already a regular sequence, then it will become unregular, and if it is regular, it will become k equals bool. Whenever I see this, and now if k equals k equals 1. If it is 1, then make it 2. Otherwise, make it 1. Equals 1, right? So now I am simply switching between two values of k. And here I do this. So I need to know if I ever went into this boolean switch equals false, sit equals false, and here switch equals true, and here switch question mark, if switch then 2, otherwise 1. Yeah, let's see if this one works. It would be nice. It's been 2 hours and 12 minutes. Why does time feel very slow? Okay, wrong answer. Okay, I can look at the thing. Test case 3. Wrong answer 2 is invalid in test case 3. Here in this one, I can shit. So this much is fine. Nope. This much is fine. Then this much is fine. And then this much. This whole thing is fine. It is in one way. And then this much is fine. Wait, this whole thing is one. This whole thing is one color. Why do I say otherwise? This whole thing is one color. Plus plus plus. Okay. 1, 2, 3, 4, 3, 2, 3, 2, 0, 0, and then 1, 2, 3, 2, 1, 0, and then 1, 2. So everything should be one color instead of switching colors. To hang brackets. Only one test case which has 18 brackets, and these are. Why do I say 21? 21 does not make sense. And then new line. Okay, that 2 came because of that. I copied another character. Okay. 18, one test case which has 18 things, 18 symbols, and one. Shit, I do not say 2, I am saying 1. So this one, okay, this is the third test case, my bad. This is 0, and I must have colored this. Okay, let's see what do I output for this. Out one test case which has 66 characters, right? And these are the characters. I say 2. 2 seems to be too much to ask. I don't know. Don't know. I don't know how to do this. I'm just unable to do these questions. I guess I am stretching my hands too much and I should read something instead. Reading. Yep. Work on some problems. Read out range queries, maybe. Bit manipulation. I like reading about bit manipulation. Bit manipulation is cool. Graphs. I've done a few graph questions. Number theory. Cool. Combinatorics. Combinatorics is also cool. Probability. I have to work on my probability. My probability is bad. Markov chains. Okay. But I do have to keep on moving. I cannot stop. Right. So if I am, yeah, I have to keep on moving. So, but I'm unable to solve these questions. I haven't even been able to solve a single question today. And it has been more than 2 hours. Shit, my heads are bad. It's been more than 2 hours. Okay. Okay, maybe we can read about bit manipulation. Yes. Refresh myself and read about bit manipulation. Okay. Bit manipulation. Okay. All data in computer programs is, wait, bit manipulation. I have to put myself in the framework, I guess, to be reading out bit manipulation. What are bits? When I am representing number in binary as 0 and 1, and now we are reading about how we can do some manipulation with those binary things, some insights into bit manipulation. Right? The framework is set. So cool. All data in computer programs is internally stored as bits, right? That is as numbers 0 and 1. This chapter discusses the bit representation of integers and shows examples of how to use bit operations, representation of integers, and shows, yep, bit representation of integers, and shows how to use bit operations. It turns out that there are many uses for bit manipulation and algorithm programming. There are many uses of bit manipulation and algorithm programming. Bit representation. Okay. In programming, an n-bit integer is typically stored as a binary number that consists of n bits. A binary number that consists of n bits, right? N-bit integer, n bits. For example, the C++ integer type uses 32 bits and it only uses the maximum range it can have is have all the 31 bits equal to 1, and the one highest bit, which is the 32nd bit, it represents the sign if the number is positive or negative. and everything 0 is equal to 0, and everything 1, I guess, is negative everything 1, and everything 1 except the highest bit is positive uh, 2 power 32 minus 1. This is the maximum positive number we can represent as an integer into max. And I think if we were to print into max, this is what we will see. Int main, yep, int a equals cout a. And what I am betting is that we will see this number. I think we should see this number. At the last, we have 9295. Max int dot slash out. And no, this is not what we see. We see here, okay, this number is much lower than this. Yes, shit makes, does it make sense if I make this? Nope, now they are equal. Now they are equal because 2 power some number. If 2 power n, then we need 2 power n plus 1 bits to represent them. Right. Right. Makes sense. So using 32 bits, I can represent 2 power 31. That is the maximum number because if I want to represent a 1, I would need 1 bit to represent that, and that would be 2 power 0. Okay, so that is cool. That makes sense. And if I were to make this negative, let's see, negative of the same value. If I do -1, we can increase. If I do -2, overflow. Let's see. Will the compiler compile? No, compiler does not compile. +1, no, compiler will not compile. Okay, cool. Yeah, so that is what we do. 32 bits. Here is the bit representation of the integer 43. 43 is 1 plus 2 plus 8 plus 32. The bits in this representation are indexed from right to left. To convert bit representation this into a number, we can use this formula. For example, this thing, yeah, cool. The bit representation of a number is either signed or unsigned. Usually a signed representation is used, which means that both negative and positive numbers can be represented. A signed variable of n bits can contain any integer between this and between this 2 power n minus 1 if we are using n bits, right? And 2 power n, the highest, minus 1. For example, the int type consists can express these things. For the negative, we can go for the whole range. It is 1. Okay, because we do not have to use 0, negative or positive. When everything is 0, then just what would be? Let's see. What would be 1 left shifted by 32, 31. So that every bit is 0 except the highest bit. And I think this should be -1. I don't know. Okay, what do I think? Will this number be equal to negative, uh, negative highest power, the biggest negative number that I can represent. So if I have this bit equal to 1, and if I add to this thing 1 left shifted, if I add to this one, let's say, okay, that makes sense. Everything, if everything is 0, then that is the highest number, and if I start by incrementing bits, that much will be reduced. Makes sense. And at one point, everything would be 0. Yes. Then we have ourselves 0. And I have to go to washroom. I will be right back. Yep, I will be right back. Bits. Yep. Okay, bits. Binary, and the main goal is for me to understand all of this that I'm reading. Yes, that is what you do. The bit representation of a number. Yes, negative. The first bit in a signed representation is the sign of the number 0 for non-negative numbers and 1 for negative numbers, and the remaining n minus 1 bits for the magnitude of the numbers. 2's complement is used, which means that the opposite number of a number is calculated by first converting all of the bits into the number in the number, and then inverting all of the bits in the number, and then adding 1. Invert all of the bits and add 1 to the thing by inverting. If the first bit is 0, it will become 1, like in this case. If it is 0, it will become 1, and everything would become 1, and adding 1 to it. Okay, that is just how you do 2's complement. In an unsigned representation, okay, my camera is running out of battery. My laptop is not charging, which is strange. Yes. I really want to stop streaming, but okay. What is the conclusion of this whole thing? That if I want a positive number, if I want its negative counterpart representation in binary, I take its 2's complement. And if I have a negative number and I want its positive counterpart representation in binary, I again take its 2's complement. Just to invert the sign, I take whatever the number I have, its 2's complement. And 2's complement is when I invert every bit and add 1 to it. Okay, cool. In an unsigned representation, only negative numbers can be used. In an unsigned representation, only non-negative numbers can be used, but the upper bound for the values is large. Non-negative numbers can be used, but the upper bound for the values is large. twice, only two times the normal representation. An unsigned variable of n bits. Okay, if I have this as unsigned, then shift count greater than width of type. No, 32. I can do that. But let's make this and then -1. Hmm. Okay, I can do maybe this. Okay, this is cool. This is fine. This is fine. And I would have the biggest unsigned integer. Unsigned int b equals int max. What is int max? Clang dot slash. What is it? It is long. It is a very long value. Okay. Unsigned int 32 max. How's that? Okay. And they are the same. They are the same, which makes sense. If I remove this, then I have error, which is cool. Okay. There is a connection between or an unsigned variable of n bits can contain any integer between 0 and 2 power n minus 1. For example, in C++, an unsigned int variable can contain any integer between 0 and 2 power 32 minus 1. There is a connection between the representation assigned number minus s equals minus x equals an unsigned number 2 power n being the number of bits used to represent the number minus x. For example, the following code shows that the assigned number x equals minus 43 equals the unsigned number this. The signed number this equals the unsigned number this. Uh, minus this thing, minus something is represented as adding this to this. So this is my integer, and y, if I make this unsigned, then this is what I have. Okay. Unsigned integer a equals minus 43, or let's say 42. After 42, this should be equal to integer b equals 1 long left 32, this whole thing minus 42. See out a with a new line. Do the same with B. Okay. Okay, they are not the same, not quite the same. To power, I'm using 32 bits to represent my number, and to power 32 minus 42. Okay, these two should be equal. They are not, they are off by 1. Did I read the thing correctly? Negative x should be equal to this thing. That is what I'm doing. Negative 42 should have been equal to 2 power 32 minus 42 minus 42 minus 42. Unsigned number this, signed, unsigned. This if a number is larger than the upper bound. This should be equal to that, but it is not. X is the number of bits that I'm using. Okay, the magnitude is same. Only the last number is different. 1 left shifted. Right. Okay, now they are same. So what was this thing doing? Okay, shit. Okay, that makes sense. Okay, that was just a coincidence. Okay. Yeah, they are the same, and this thing is correct. That is cool. And I think I can stop the stream here for the day. For the day, that is. Yep, I think I can stop the stream for the day, and this would be it for today. And thank you for being here, and I will stream daily, and after the stream I will maybe take a walk and then get back to reading. Re-strategize. Yep. And thank you for being here. Bye.